Morning, students. Today we can discuss about a problem and nodal analysis in the subject electron devices and circuit theory. So the nodal analysis, we will be applying Kirchhoff's current law. So this is the question. It is to find all the nodal voltages for the given circuit. So first we can mark out all your branch currents. So this is one branch. You can take it as I1 and this is I2, this is I3, this is I4, this is I5, and there are how many nodes? This is one node. We can name it as node 1. This is another node. Name it as 3. So 2. And this is another one node. Name it as 3. And this is another one node 4. That is nothing but the reference node. The reference voltage is equal to 0 volt. Okay. So this particular problem, so first we can write down the nodal equations. For that nodal equations, we have to apply KCL at node 1. So KCL at node 1. So what it indicates, sum of the incoming currents is equal to the sum of outgoing currents. So how many branches are meeting at this junction? There are three different branches, and I1 and I2 are the outgoing currents and 3 is the incoming current. Okay. So I1 plus I2 is equal to 3. So what is I1? The node voltage at this node is, we can take it as V1, this is V2, and this is V3. So V1 minus V2 by 1 plus, and the second one is between node 3 and the 2 ohm is between node 3 and 1. So V1 minus V3 by 2 is equal to 3. So V1 1 plus 1 by 2 minus V2 minus 1 by 2 V3 equal to 3. 1 plus 1 by 2 is 3 by 2. It is 1.5 V1 minus V2 minus 0.5 V3 is equal to 3. Take it as equation number 1. Now apply KCL at node 2. So at node 2, there are how many branches are meeting? There are 3 branches. I2 is the incoming current and I4 and I3 are the outgoing current. So I2 equal to I3 plus I4. So what is I2? It is V1 minus V2 by 1. And what is I3? It is V2 minus V3 by 4. And what is I4? I4 is between the reference potential V reference and V2. So V2 minus 0 divided by 3. So it is V1 minus V2. So bring all these equations to this one side. 1 plus 1 by 4 plus 1 by 3 minus, so this minus it becomes plus here. So plus 1 by 4 V3 equal to 0. So this is V1. So V1 minus 1 by 3 plus 1 by 4 plus 1 by 3. It is some 1.585 V2. And what is 1 by 4? It is 0.25 V3 equal to 0. So that is nothing but the second equation. Now you have to apply KCL at node 3. So at node 3, there are 1, 2, 3, 4 branches meeting. In these 4 branches, so this is nothing but I1, sorry. There are 4 branches. What is sum of the incoming currents? I2 is the incoming current. Then I3 is the incoming current. And 7 is the incoming current. And I5 is the outgoing current. Okay. So what is I2? I2 is nothing but V1 minus V3 divided by 2. And what is I3? V2 minus V3 by 4 plus 7 equal to what is I5? It is V3 minus 0 divided by 5. Okay. So now simplify it. 1 by 2 V2 plus 1 by 4, sorry, V1. 1 by 2 V1 plus 1 by 4 V2 minus V3 into 1 by 2 plus 1 by 4 plus 1 by 5. If you are bringing this V3 towards this side, it becomes 1 by 2 plus 1 by 4 minus, so it is plus 1 by is equal to minus 7. So it is 0.5 V1 plus 0.25 V2, 1 by 2 plus 1 by 4 plus 1 by 5 becomes 0.5 plus 0.25 plus 0.2 is equal to minus 0.95 V3 equal to minus 7. That is your equation number 3. Now you have to simplify this. So simplify by applying Cramer's rule. So what is the first equation? The first equation is form it as matrix 1.5 minus 1 minus 0.5. Second equation it is 1 minus 1.585 0.25 and 0.5 0.25 minus 0.95 into V1, V2, V3 equal to 3, 0 minus 7. Okay. First find del. Del equal to determinant of 1.5 minus 1 minus 0.5, 1 minus 1.585, 0.25, 0.5, 0.25 minus 0.95. So it is 1.5 into 1.58 minus into minus becomes plus 0.95 minus 0.25 into 0.25 minus into minus becomes plus. So plus 1 into minus 0.95 minus 0.25 into 0.25. Next minus 0.5 into 0.5 into 0.25 into 1. So 0.25 minus into minus becomes plus 1.585 into 0.85. Okay. So you will be getting the del value should be equal to 1.5 into 1.598585 into 0.95. So it becomes some 0.565. 0.565. Then what is del V1? Del V1, for you have to replace the last equivalent side, right hand side by to the first column of the determinant. So it is 3, 0, minus 7, 1, minus 1.585, minus 0.25, 0.5, 0.25, 0.95. So it is 3 into minus 1.585 into 0.95, minus into minus becomes plus, plus 0.25 into 0.25, minus 1 into 0 minus into minus becomes plus 0.25 into 7, plus 0.5 into 0 plus, sorry, minus 7 into 1.58, which becomes 7 minus 7 into minus 7 into minus 1.585 becomes minus into minus becomes plus. So what is del V1? Del V1 equal to 2.967. So what is your value of V1? Del V1 by del, it is 2.967 divided by 0.565, which is equal to 5.25 volts. Okay. So first V1 we have found out. Then we have to find V2. So for that we need del V2 by del. So what is del V2? You have to replace the second column of the determinant. So 1.5, 1.5, 1.5, 1.5, 3 by the right hand side. So 3, 0, minus 7. Then 0.5, 0.25 and 0.95. Okay. So del V2 equal to 1.5 into 0 minus into minus becomes plus 7 into 0.25 minus 3 into 1 into 0.95 minus 0.5 into 0.25 plus 0.5 into minus 7 minus 0. So what is the value of del V2? By solving this, you will be getting approximately 2.9. Now what is the value of V2? Del V2 by del. So it is 2.9 divided by 0.565, which is equal to 5.13 volts. Okay. Then we this calculate to V3. So for that, replace your last column by 3, 0, minus 7. So what is the remaining values? 1 minus 0.1585, 1 minus 1.585 and minus 0.25. So now calculate the value 1.5 into 1.585 into 7, because minus into minus becomes plus, minus 0, minus 1 into minus 7 minus 0 plus 3 into minus 0.25, minus into minus becomes plus 0.5 into 1.585. So what is the value of del V3? Del V3 6.497. So what is the value of V3? Del V3 by del. So it is 6.497 divided by 0.565. So the V3 value is equal to 11.49 volts. So we have calculated all the nodal voltages V1, V2 and V3. So this is the steps you should follow for the nodal analysis. Hope you have understand. Thank you.